All right, let's go ahead and take a look at number 2. Just like the last one, we can go ahead and try to plot these points on our graph, so go ahead and take the time to do that. Again, you might not be able to graph all of them, but at least it'll give us a good start. And if you were to try to connect the dots, it might seem at first glance that this would be a parabola shape. I know most of us are familiar with that U shape, but if you were to graph or plot and trace these points, they would be more linear, which would be creating a V shape. All right, so a V-shaped graph is hopefully signifying to us that we are dealing with an absolute value function. I like to remember value for V. Okay, it has that shape of a graph. And if we try to go ahead and tackle some of these properties like domain and range, we'll go ahead and check this out. So if we drag our pencil left to right across that V shape, we will be touching every single point on that graph. So again, we have all real numbers. The range, though, in this case is a little different from the line. Notice how this graph starts at a y value of -3 and then goes up forever. So that's for this particular example, but we can draw a V shape really anywhere on a graph and its range would change. So notice how depending on how low or how high your vertex of that V or where that's located, your range will change. So I'm just going to say changing in this example, but it specifically would be -3 to infinity. So maybe we'll say changing, but from -3 with a bracket to infinity with parentheses for this particular case. Looking at our graph, there are no holes, no jumps, or asymptotes, so we can say no discontinuities. If we look at this constant slope idea, if we were to calculate the rise over run, looks like we go down 1, 2, 3, 4, and over 2 on the left-hand side, but notice how that's an opposite slope for the other side of the V shape. We go up 4 and over 2. So it's a different slope, but they are opposites of each other. So we can say that an absolute value has a constant, because after all they are lines. Okay, lines have constant slopes. They are constant, but opposite slopes on each leg. Now this brings into question, if we're talking about slopes, what is the slope at the very bottom point? Okay, are you actually able to calculate rise over run at the very bottom? Notice how at the very bottom or the vertex, that's where the slope changes. It goes from having a slope of -2 to a +2. So just as a little tidbit fact here, maybe we'll throw in a star because we are going to discuss this year. We'll say that we have no slope at the sharp point or vertex, if you want to be more specific. Now those are some good properties I think that we can list about absolute values. Let's go ahead and try to figure out the equation of this graph. So we'll go ahead and label this one g of x. After all, that's what it's named at the top. Absolute values, typically the V shape starts at the origin. Okay, that's where the vertex begins. But notice how this vertex was moved a little bit. So we can probably utilize transformations of functions to help us write this equation. So we'll go ahead and throw in the absolute value bars. If the vertex normally starts at the origin, notice how this one was moved left 2 units. So we would need an x plus 2 within those absolute value bars. And then the vertex was also moved down 3 units. So we would need a -3 on the end. We do not need a negative sign out front because we do not have an upside down V in this case. It's a regular V pointing upwards, so we don't have to worry about that negative.